right, hi class. So today we're going to do a homework review because some of your classmates expressed some confusion on some of the homework. So I picked the B problem on all of the homeworks to just run through with y'all to make sure y'all felt like you understood how to do it. So if you felt really competent in the homework and don't feel like you need to review, this video is just purely for if you would like a little extra understanding on the homework. So it's not required for the class or anything. So we're going to start with 1B. So this was where we needed to use the rational zeros theorem and find the possible real zeros and then solve for them. So here, first we look up here and we see that the leading coefficient is -1. Well, the factors of that are plus or minus 1. And then the factors of 8 are plus or minus 1. That should be a minus, not just a little line. Okay. So plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. So these are all of the factors of 1 and 8. And so now we're going to go through and we're going to check 1, minus 1, 2, minus 2, 4, minus 4, 8, and minus 8. So on this one, you just will take, like for the first one, I'll walk us through it and I'll kind of speed through some of the later ones because just watching me do computations is not the most helpful for y'all. But so we'll plug 1 in and we'll see it's a minus 1, then a plus 6, a minus 2, a plus 4, and a minus 8. And this equals -1. So this does not equal 0. So 1 is not a 0. And then if we do -1, so we have our x to the 4th. Well, -1 to the 4th is +1, so we still get a -1. And then here we'll get a -6 because x -1 cubed is -1. And then we'll get a -2, then a -4, and a -8. And since we can notice that each one of these is a negative number, we know that when we add them together, that will for sure not equal 0. And then if you were to go through and compute all of these, you will see that all of these actually do not equal 0. And this is very possible with the rational zeros theorem. The whole point of that theorem is that if you have a rational root, it will be of this form. So that means that our roots are either irrational or complex. I wanted you guys to have kind of an understanding that this theorem doesn't always work. That's why I had this problem on the homework and why it might have seemed kind of funky that you didn't get any of them actually being zeros. It's just letting you know that you can have a polynomial that has funky roots, so it's either irrational or complex. And if you don't remember what an irrational number is, that's something kind of like the square root of 2 or pi. They are not, you cannot write them as fractions. So they are, they have a non-repeating decimal representation. And that's all just kind of fancy for, it's usually like the square root of a prime or something like pi, or e is another one. And then a complex number is of the form a plus ib, where a and b are real numbers and I squared equals -1. All right. So then if we move on to problem 2, so that's 2b. So this one we're looking at p of x equals x cubed minus 3x minus 2. And we're supposed to factor it out and write what all of the zeros are. So here we're going to use the same rational test. And so the factors are plus or minus 1. And here the factors are plus or minus 1 or plus or minus 2. So now I'm just going to, the goal of this is you can kind of run through and check some of them to see which one is a 0. I've done a little computation ahead, and I know for sure that 2 is a 0. So let's try 2. So I'm going to use synthetic division to factor this out. We're going to have a 1, and then we have a 0 because there's no x squared case, then a -3 and a -2. 2, add down is 2, multiply is a 4, we add, we get a -1, and we multiply and we get, I'm sorry, a +1, sorry. -3 plus 4 is +1. And then when we multiply, we get another 2. And this is a 0, which is exactly what we thought should work since 2 is a 0. So then our next polynomial, so we can rewrite p of x equals x minus 2. Since +2 is our 0, it's x minus 2 is our factor, because when we plug 2 in, we will get 0. And then it's with x squared plus 2x plus 1. And now we're going to factor this new polynomial we got from dividing out. So we could either do this, because it's a quadratic, so it has this nice squared form here. We could either do the quadratic formula, or we could do the rational zero test and test some possible zeros. Or there's a nice trick that sometimes works with quadratics. I think you might have learned it in high school. So you put, I put our 1 and our 2. So what it is it's what you multiply to get and what you add to get. So here, if we look at 1, 1 plus 1 equals 2, and 1 times 1 equals 1. So that lets us know that we could probably factor this polynomial out, and it will be x plus 1 times x plus 1, which also just equals x plus 1 squared. So you find the factors of your constant term, and you want to find 2 that when multiplied together will give you your constant, but when added together will give you the term in front of x. And I think y'all should have learned how to factor quadratics in 116. Okay, so now we know what the fully factored form is. P of x is x minus 2 times x plus 1 squared, and the zeros are 2 and -1. Okay. So then going on to 3b. I was looking at our polynomial x. Okay, we have -x to the 4th plus 10x squared plus 8x minus 8. All right, so again, we have a plus or minus 1 in our leading coefficient, and our factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. So let's try -2. And this one, again, I did go through and check a couple of them just beforehand, just running through some calculations to make sure that it worked. So if we try -2 in here, just to see, to make sure, we have -2 to the 4th plus 10 -2 squared plus 8 times -2 minus 8. Well, this will give us a -16 plus 40 minus 16 minus 8. Well, if we add these 16s together, we'll get a -32, and then minus 8, that gives us a -40, and then with this +40, they cancel, so this does equal 0, so therefore -2 is a 0 of our polynomial. So now we're going to factor it out. So if we do, I'm going to do synthetic again, just for ease. I'll do a long division example later. All right, so since -2 is our 0, we'll write it like this. And then we'll write the coefficients. So we have a -1. And then we have a 0 because there's no x cubed. And then a +10, a +8, and a -8. All right, -2 times -1 is 2. We add and get a 2. We multiply a -4. We add and get a 6. We multiply and get a -12. We add and get a 4. A -4, sorry, because -12 is bigger than 8. We multiply and we get an 8, and then we have a 0 remainder, which is what we wanted. That makes sense. And I know I'm running through some of this division quickly. If you're still feeling confused on that, the lecture for synthetic and long division is lecture 3.3, I believe. So you can always rewatch that, and I run through these sort of steps slower. All right, so then this new polynomial we have is -x cubed plus 2x squared plus 6x minus 4. So now we're going to do the same steps again. So here our factors are plus or minus 1, and then our factors are plus or minus 1, plus or minus 2, and plus or minus 4. I'm going to try -2 again. And again, I've run through these computations before, and once you find one 0 that works, you're good. You don't need to check all of them. So if we do -2 again, and we divide it out, we get a -1, a 2, a 6, and a -4. A -1, a 2, a 4, a -8, a -2, +4, and a 0, which again checks out. So that really does mean that -2 was a 0 twice. So now our new one is -x squared plus 4x minus 2. So if we're trying to do a similar technique as before, where we're trying to look at factors of -2 that when multiplied add to 4, it's pretty impossible because the only numbers that will add to 4 are like 1 and 3 and 2 and 2. But the problem is with 2, the only factors are 1 and 2. And to get a -2, we'll need like -2 times +1. But that will not add to 4. So if you have something that's kind of messy like that, that's a good signal that you need to use the quadratic formula. So that's what we're going to use to factor this one. And you can always go to the quadratic formula, and that one will always work for our quadratic of anything with x squared. So if we're using the quadratic formula, so remember that is -b plus or minus the square root of b squared minus 4ac all over 2a. Where this is a, b, and c, are coefficients in these places. So here we have -4 plus or minus the square root, 4 squared is 16, minus 4, -1, -2, all over -2. And here, oops, in parentheses there, this will give us a 16 minus 8 over -2. So then this becomes -4 plus or minus the square root of 8 all over -2. I'm going to factor this 8. I'm going to rewrite it as the square root of 4 times 2, because I know the square root of 4 is 2. So that'll let us rewrite this as -4 plus or minus 2, the square root of 2, all over -2. And so then simplifying again, we will get a 2 plus or minus the square root of 2. Oh, not over anything. We just used that 2. Oops. Okay. So these are our other zeros. So now when we write it in factored form, we will have p of x equals x plus 2 squared, since remember up above we had 2 times where -2 was a 0, and then an x plus 2 sorry, that should be a minus because this is our zeros. So we write that with a minus. All right, so x minus 2 minus the square root of 2, and x minus 2 plus the square root of 2. So this is our factored form, and then we will write our zeros as negative 2, 2 plus the square root of 2, and 2 minus the square root of 2. And now when we graph it, so we can, looking at the original equation we had, it was negative x to the 4th plus 10x squared plus 8x minus 8. Well, here, our coefficient, or our degree is even, and our coefficient is negative. So that means that for our end behaviors, y approaches negative infinity as x approaches infinity, and y approaches negative infinity as x approaches negative infinity. Okay, and we also know our zeros. So if we were to put it on a graph, we have negative 2, 2 minus the square root of 2, and 2 plus the square root of 2. And we know that these will be 0. And then we can check a point in between each one. I picked 0 and 2 because I thought that would be the best. So when we have a 0, we'll have an intercept here at negative 8. And if we were to plug in 2, I'm not going to give you the actual value because that can get kind of long, but it is positive. Okay. So that means that, and since our graph is coming from the negative direction on both sides, and that, so this means that it will just kiss the x-axis here. It'll hit x equals 8, and then it'll come up, and then down again. And again, I do not mind where exactly the extreme points are. You don't need to find those when doing this. I only care about, for your graphs, the end behavior, the y-intercept, and the x-intercepts, which are our zeros. So as long as you have just the basic shape of your graph, that's really all that I need. All right, so moving on from here, we will look at 4b. So in this one, we're using Descartes' rule of signs, and we're going to look at the number of variations. So first, we're going to rewrite our polynomial. This is negative x to the 7th plus 6x to the 5th plus 5x to the 4th minus 6x cubed minus x minus 6. So in this case, we have a variation here and a variation here, because we have a negative to a positive, and then a positive to a positive to a negative to a negative, and then to a negative again. So we have two variations. And now we're going to look at p to the negative x to find the negative variations. So that means that on all of the odd terms, or odd powers, our signs are going to switch, because when you take an odd power to a negative 1, so like negative 1 cubed equals negative 1, or negative 1 to the 4th equals positive 1. Oops, don't know why it's erasing so much sometimes. Okay. So then we will have an x to the 7th minus 6x to the 5th plus 5x to the 4th plus 6x cubed plus x minus 6. Because remember, there's like a little secret 1 on our x's. Okay. So we have a variation here, a variation here, and a variation here. So that's 3 variations. So what that means is our possible positive zeros, we have 2 or 0. Our possible negative are 3 and 1. So remember, when we're doing this, you take the number of variations and then you subtract 2 going down until you reach 0 or a negative number, because you go down by an even multiple. That's the possible numbers. So that's why for our possible negative, we have a 3 and then a 1. You can't have -1, 0, so we stop when it would like go past 0. So now our possible total is all combinations of adding these. So 2 plus 3 is 5, 2 plus 1 is 3, 0 plus 3 is 3, and 2 plus 1 is 2, and 0 plus 1 is 0. So these are our total possible, because we did all possible combinations when adding our possible positive and possible negative. All right, I didn't do 5 because that was just explaining something in your own words. So that's definitely a personal problem for each of y'all to have written. And so now I'm going to move on to 6b. All right, so we have p of x equals x cubed minus 8. So again, the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Well, just looking at this, it's pretty clear that 2 will be a factor because 2 cubed is 8, and 8 minus 8 is 0. So we're going to divide 2 out. So I'm going to do long division with this one. Oops, I actually should lower this a bit. And remember, when a positive 2 is our 0, we're going to write it as x minus 2. So then we have an x cubed plus a 0, x squared, plus a 0, x minus 8. And so we need to have an x squared here, because x cubed minus x squared, or 2x squared. And we subtract this, we get a positive 2 x squared, and we pull down a 0x. And now we have plus 2x squared minus 4x, sorry. And we subtract, and we will get a positive 4x. We bring down our negative 8, and we will have a plus 4 here. And we will have a 4x minus 8, which will give us our 0. So this gives us our remainder is 0. Perfect. So that's good. This verifies that this is for sure a 0. And now we're going to factor this other quadratic that we got. So we got an x squared plus 2x plus 4. So this is pretty clear that this should be able to factor into an x plus 2 times x plus 2. So when you FOIL this back out, it should match exactly. And it's a similar thing where the factors of 4 are plus or minus 1, 2, and 4. Well, 2 plus 2 equals 4. Oh, wait. No. This is wrong. I'm sorry. This is wrong, guys. I did my math wrong. No, it does not factor like that, so we'll need to use the quadratic formula. Sorry about that. All right, so we'll have a negative b plus or minus the square root of b squared minus 4ac all over 2a. So then writing it out, we'll get a negative 2 plus or minus the square root of 2 squared is 4 minus a 4, 1, 4 all over 2. So this will equal -2 plus or minus the square root of 4 minus 16 over 2. So then this will give us a -2 plus or minus the square root of -12. So -12 I will rewrite as the square root of 4 times the square root of -3. Actually, no, I'm gonna choose -4 and the square root of 3. So there's a little secret negative there. So we're gonna rewrite as -2 plus or minus 2i times the square root of 3 over 2. So our actual 0 is -1 plus or minus the square root of 3i. So this is our 0. So this is a complex 0. So that means our factored form is p of x equals x minus 2. Remember, that's from up here where this worked out. And then times x plus 1 plus this cubed root of I, and x plus 1 minus the cubed root of I. And then remember, since this is a 0, when we rewrite it, it's like x minus this whole thing is what happens. Okay, so then our zeros are 2 minus 1 plus the cubed root of I and minus 1 minus the cubed root of I. Okay. Perfect. I think I said the cubed root while writing the square root of 3 a bunch there. That's the wrong word. I should have been saying the square root of 3. Sorry about that. All right, and then going on to our last problem, 7b. So we're going to have p of x equals x to the 4th plus 3x squared minus 4. And now, a good trick when you have a polynomial raised to the 4th, where our next term is something like 3x squared. So I'm going to make a substitution. I'm going to say that y equals x squared. So then our p of y is y squared plus 3y minus 4. Well, this is a quadratic that we know how to factor. And this one's pretty obvious that if you have a -4 times +1, that'll give you -4. But -4 plus 1, oops, sorry, this one. I got the negative on the wrong side to make this adding work. So sometimes that happens. You're like, oh, this should work. Let's see where the negative sign needs to be. Okay, there we go. And a 4 minus 1 is 3. So that will give us our 3y and our -4. So that means that this factors as y minus 4 and y plus. Again, I'm sorry. I keep writing these negative signs a little backwards. Y plus 4 and y minus 1. All right. And so then we need to rewrite with our x's. So this will become x squared plus 4, x squared minus 1. And then when factoring these, you should remember from 116 that when you have something like this, the x squared minus 1, this is x minus 1 times x plus 1. And then when you have something similar, when it's x squared plus a number squared, that means you'll have x plus 2i and x minus 2i. So that's like a really good form of when you have the two ways with the x squared plus or minus a number. When it's positive, it'll be the square root of the number with an I term. And when it's like x squared minus a number, it'll be plus or minus the square root of it, but as a real number. Okay. So that means our factored form is x plus 2i, x minus 2i, x minus 1, x plus 1, and our zeros with multiplicity are 2i mult 1, negative 2i mult 1, negative 1, mult 1, and 1 mult 1. Perfect. All right, so that was a quick overview on how to solve each type of problem on the homework. I'm sorry that it was a little confusing this time. Homework 3 should be more straightforward and should have a lot less mistakes in it. All right, I hope this was helpful in your understanding of last week's material. All right, thank you.